My name is Salomi Seeram. I am a coastal scientist at Coastal Dynamics Limited, which is one of the leading local environmental consultancy companies for the past 24 years. My academic journey for CSEC and CAPE was science-based. Based on my performance at CAPE, I was awarded a national scholarship and went to UE to pursue a bachelor's in biology. After this degree, I changed fields to focus on the marine aspect by doing the Master's in Marine Environment and Resources through an Erasmus Mundus scholarship. This master's provided valuable knowledge and experience in physical, biological, and chemical oceanography, which is the study of the oceans, and marine geology. Currently, I'm pursuing a master's in geoinformatics, which aims to provide solutions to real-world problems through the use of spatial data. In other words, this is real-world data that is captured, stored, managed, analyzed, and visualized, example through maps, within geographic information systems. Another example is like ArcGIS products. Prior to satellites, data had to be collected by going out into the field to conduct surveys and then processed and analyzed using relevant programs. Example, Excel can be used to process and analyze some data. Additionally, models have been created to represent the real world through mathematical equations, and for example, the National Centers for Environmental Prediction, which is a part of NOAA, have created models for different environmental aspects. These models, however, usually rely on some sort of measured data to calibrate and validate itself. There are various examples of how satellites can be used in the environmental field as well as within the national and regional context. I shall just be highlighting a few of them. Aerial imagery can be used over different time periods to show the changes in the land use or land cover. For example, here we can see the difference in the mangrove extent at Point Lisas between the 1994 satellite aerial imagery and the 2014 aerial imagery, where there is significant growth of mangrove. Imagery can also be used to track shoreline changes, and CDL recently conducted a coastal vulnerability index for a government agency as part of a national project. Part of this project identified coastal areas that are at risk from coastal erosion and flooding in relation to sea level rise. The same 1994 and 2014 aerial imageries were used to determine the rate of shoreline changes along the nation's coast. And as you can see here, a carcass is an example of an area that showed erosion. Another example of how satellites can be used in this field is by using satellites to measure the sea level through radar, which emits radio waves to determine the water depth. This is helpful as sea level rise is a major climate change impact that will negatively affect the coastline through the same coastal erosion and flooding. As such, this data can be used to determine sea level changes, which can be used to model future sea level rise. An example of such a climate model is the coupled model intercomparison project that the Intergovernmental Panel on Climate Change uses to report projected climate changes in the future. Satellite radar can also be used to measure bathymetry, which is the water depth, to provide the topography or layout of the ocean floor. This is particularly helpful as it can be measured over large areas, which would have been difficult and expensive to do in the field, or over areas that are inaccessible in the field. As previously mentioned, numerical or mathematical models can be used to represent the environment and its natural processes. One such local model is CDL's in-house HD model, which can provide information to better understand the ocean currents around Trinidad and Tobago and within the Eastern Caribbean up to St. Lucia. Additionally, through the use of satellite data, CDL's model has forecasting capabilities up to 7 days. In order to derive information from the model, the boundaries are inputted from various sources. These datasets include wind data from GFS, which is a weather forecast model from NOAA's National Centers for Environmental Prediction, water levels from DHI, which is an international water software development and engineering consultancy firm based in Denmark, temperature, salinity, as well as horizontal and vertical velocities from Copernicus, which is a European satellite program. This is just a visual example of the boundary data from the Copernicus program, whereby data is obtained for the different boundary locations. As you can see, the datasets also extend into the water depth. This is an example of the model output, whereby we can see the current speeds at the surface as well as within the water column. These outputs can be used for further applications to determine how, when, and where the environment can be impacted. For example, you may have noticed that in recent years, the Caribbean has been experiencing increasing events of brown algae known as sargassum washing ashore on coastlines. While these events hamper the use of the beaches and coasts, these algal mats can also impact marine organisms such as the sea turtle. While satellite imagery provides a good tool to detect the sargassum, a forecast model such as CDL's own can be used to track these algal mats prior to the bleaching event. This would be useful for the relevant authorities as they can be made aware of the precise coastal areas that would be impacted and minimize these impacts of the sargassum to the areas. Additionally, satellite imagery can also be used to detect oil spills, which are a major problem as it damages both the marine and coastal ecosystems in the area. This detection can allow for more efficient and effective oil spill cleanup efforts, as it can then be tracked using the relevant trajectory models to reduce the negative impact on the environment.